Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we're going to go through 8 problems and solve them all by a different type of factoring method. Okay, so the very first 2 problems that we have are going to be solving by factoring. Now, this is attached to a worksheet that a student gave me, brought in, or that her teacher said, hey, this is a nice review of the chapter. Let's start with these. And so this is the first 8 problems of this chapter review. It's linked with Big Ideas Chapter 3. It's all on factoring, graphing. Some of the things in here are word problems on quadratics. Um, we're also looking at using imaginary numbers, complex numbers, things of that nature. And we're also going to look at systems of equations and systems of inequalities in this whole thing. So it's a really big action-packed chapter. But this video is just going to cover this. This is going to be like a part 1, and then we'll have part 2, 3, 4, or more later. Okay. So this one says solve by factoring. We're going to factor, and we know that anytime we factor, our goal is to have all of this on one side of the equal sign, 0 on the other. So that way we can open up 2 sets of parentheses. We know that our first term within those 2 sets of parentheses, so the thing that's going to be here and here, is going to be my factors of that first term. So in this case, I know that it's going to be just x and x. And then in my second term, I'm going to have in here and here, I'm going to have my factors of the last term. So -16. So one thing that I always recommend to students when you're factoring in this fashion, absolutely always just write in the factors of this number. And it doesn't have to be positive or negative. We can focus on the positive or negative a little bit later. But for now, we're looking at 1 times 16, right? 2 times 8. 3 doesn't go in, 4 times 4. Okay, well, now we have 4 times 4. We're going to go back down to 8 and then 16. So these are all of my factors. And then I want to try and look at these and say, okay, which one of these 3 sets are going to give me either by adding or by subtracting this middle number in here, this number 6, okay? So this is, I want my factors to add to this and multiply to that, right? So in this particular case, I know that 8 minus 2 is going to give me 6. So I can right away write 8 minus 2. And when I'm looking at this number, -16, I know one of my factors has to be negative, one of them has to be positive. So I'm going to end up with +8 and -2. Let's say you're at a point in your life and you're like, dang, I don't remember how to factor. It's totally fine. Um, my my Algebra 1 teacher from way back when would always tell me this trick on how can you check it. So instead of foiling it out and bringing it back to the original problem, all you need to do is just the inner section and the outer section. So just the O and the I. So for example, when I do the I, right, the inner 2, I'm going to end up with 8x. And when I do the outer 2, I'm going to end up with -2x, right? Because this is actually a -2. And when I add these 2, I end up with 6x. And this is kind of like my check. If this guy looks like this guy, then we're good, right? And so when we're being asked to solve by factoring, we then go in and we say, okay, so now I know these 2 are properly factored. I'm going to have x plus 8 equals 0, x minus 2 equals 0. I'm going to subtract 8 from both sides and end up with x is -8. And I'm going to add 2 and end up with x is +2. And that's all I would do in order to factor this. So moving on to the next problem, when I have one that doesn't have an equal 0, I need to make it equal 0, right? So what I'm going to do is I'm going to move this guy over to the other side by subtracting 13. So I'm going to have -13x plus 3 equals 0. And then I'm going to go ahead and I'm going to open up my 2 sets of parentheses because that's how I solve by factoring. I know that my first term is going to need to be factors of this. So now options that I have are going to be 4x times x, or 2x times 2x. I'm going to go ahead and I'm going to start with 4x and x, only because I know what the answer is. So that's where I would go in. You'll see when you do the inner and the outer, like over here later on, if you started with the 2x and 2x, you'll see that it does not quite work out the way that the way that you want it to. Okay. Then I know that I have 3 as my number that I'm going to go ahead and find the factors of 3. So for 3, I know it's just 1 and 3. There's no real like other factors going on. So I'm going to try +1, +3. Let's see what happens. I'm going to go in, I'm going to do the inner. That's 1 times x is 1x. 4 times 3 is 12x. And when I add these two together, I get 13x. Now the problem is that I don't want 13x, I want negative 13x, right? So in order to make this negative, I got to make sure that this is negative and this is negative. Well, in order to make these two negative, I'm just going to go in and I'm going to make these two both negative in here and in here. So now I fully factored. Now this guy looks like this guy in the middle, and so we're in a good place. So now I have 4x minus 1 equals 0 and x minus 3 equals 0. I go ahead and I add 1 to both sides. So 4x equals 1. Divide by 4 on both sides. So x equals 1/4. This is totally an acceptable answer. The further you go in math, the more gross your answers will be. So definitely expect to see fractions and like weird looking fractions like 17/3. That's totally an acceptable answer when you're looking at Algebra 1 problems. The method of solving them, they're just more challenging. Okay, so now we're going to go ahead, we're going to solve this by square rooting. So when we're square rooting, one thing that I want you to notice is that we only have 1x squared. See, so their x shows up only once in both of these problems. So when we have that x shows up only once, our job is to get this guy by himself, and we want it to equal something else. So in order for that to happen, we're going to subtract 49. Subtract 49. I'm going to just do some quick maths here. Oops, that's a 7. So that'll be 36. Once I get to this point, I know that I can square root both. And I know the square root of x squared is just x equals positive, negative. Please do not forget that, because both positive 6 and negative 6 can add up to, can multiply up to 36, okay? And then that's it. It's that basic. This is my final answer. I feel like sometimes when we solve by square rooting, if we're capable of solving by square rooting with that type of problem, definitely 100% do it. Don't go in and try to like factor things. It's just going to make your life a lot harder. Okay, so now let's go into this one. Now this one has a fraction. Normally we don't like fractions, so we're going to get rid of them, although I love fractions, but I'm sure most of my students don't like them, so here we are. I'm going to put 10/1, I'm going to multiply across, and I'm going to be left with x plus 1 squared equals 40/3. Now, when I square root this side and square root this side, I'm going to notice that I'm going to have root 40 over root 3. That is not allowed. Root 3 is not a thing. I can't have a radical in the denominator. So what I need to do is I need to actually go in and I need to rationalize that denominator. So in order to rationalize a denominator, I'm going to go ahead, I'm going to multiply by root 3 over root 3. I'm going to end up with root 120 over regular 3. So that's doing this math to make sure that this gets into a normal number without a radical in the denominator. So I'm going to end up with x plus 1 equals, again, both positive and negative, square root 120 over 3. Options for this are, if you're allowed a calculator, definitely go in, solve whatever the square root of 120 is, divide that by 3, get whatever that answer is, move on by subtracting 1 from both sides. The instructions for this particular assessment, though, or review sheet, are no calculators allowed. So instead, what we're going to do is we're going to take 120 and we're going to factor tree it. So we know that that's going to be 12 times 10. We know that that'll be 6 times 2 and 2 times 5. I know that this is the only pair that I'm going to have available for me with two things. So I can rewrite this as x plus 1 equals positive negative 2 square root 30 over 3. I'm going to subtract 1 from both sides. So I'm going to end up with negative 1 plus or minus 2 root 30 over 3. I can also go in and replace this and make it negative 1 over 1 plus that whole business so that I can change these guys to both 3 and 3. So that instead of having like this is kind of like a negative, like whole one, I can end up with negative 3 plus or minus 2 root 30 over 3, like that. So that is all under one big fraction instead of a whole number and then a fraction combined together. I think both are totally acceptable answers. It just depends on what does your teacher. Okay, so now here we are solving by completing the square. One of the things that we notice is we have an x squared and an x. So we want to have those two on the same side. And this number right here, we want it separate. We want it away from the rest of the pieces. So we're going to replace that. We're going to do x squared minus 6x. And we know that when we complete the square, we're going to have to add something to both sides of the equal sign, minus 7 plus something else. And that something else is always going to show up in this negative b over 2, not negative b. Oh my goodness. There's just too many b things going on, b and 2 and b and a, b over 2 squared. One thing that I tell all of my students is I know that showing your work is like not cool, but doing this, especially when you have a problem with fractions, is going to be super helpful because you don't have to think about, oh, what's the number that I'm going to need to put in into each set of parentheses, okay? So we know that b is this middle term here that's always attached to the x. So I'm going to have negative 6 over 2 squared, make it negative 3 squared. And this is the number that you're going to put in when you open up two sets of parentheses. Even before I solve this, I know that I'm going to have this going on, okay? And then once I have that squared, it's going to be 9. So I'm going to add 9 here and add 9 here. When I look at, I don't know why there's like a ginormous space over here. Let's fix that. When I look at this type of problem to factor it out, I know that 3 times 3 is actually 9 and 3 plus 3 is actually 6. But if I have them both negative, then I'm going to do negative 3 plus negative 3 and get negative 6. And then this just becomes 2. And then I go in and I simplify this side because I know that if I have two of the same things, I can go in and say, hey, I have something squared. And then this becomes the problem that we just did where we are square rooting the problem. So I'm going to square root this guy, square root this guy. X minus 3 equals positive negative square root 2. Add 3 to both sides. Final answer. Okay. Let's take a look at something that's a little bit more wonky. I'm going to replace these k's with x's because I can. I don't like any other variable other than x. It's my favorite variable. And one thing that I'm going to notice is that each of these terms of mine are fully divisible by 4. So I'm going to divide all of them by 4. And if I divide something on one side by 4, I'm going to divide it on the other side as well. To simplify it, to make my life a little easier. So I'm going to have x squared plus 2x plus 3 equals 0. Then I'm going to remove this 3 over to the other side and leave that like plus business. Plus something equals negative 3, right? Because I'm moving it to the other side. And then over that. Okay, beautiful. So now I'm going to go in, I'm going to do the same business of b over 2 squared. So b over 2 is going to be 2 over 2 squared, which is 1. 1 squared is just 1. So I'm going to add 1 to both sides. So now I can open up my two sets of parentheses. Or after doing this so often, we don't even need the second parentheses. We can just do parentheses squared. Because we know that this is the number before we square it, that's the number that's going to go in here. So again, I know 1 times 1 is 1, 1 plus 1 is 2. So that gives me this fully factored, -2, and then I can go in and square root both sides. X plus 1 equals positive and negative. Now, because this is a -2, I'm going to have to deal with imaginary numbers. So it's going to be I root 2. Then I'm going to subtract 1 from both sides, and I'm going to end up with -1 plus or minus I root 2. Again, totally acceptable answer to have these complex numbers, to have these imaginary numbers in our work. Okay. For those of you who do not yet know the quadratic formula, it's on TikTok. There's a song, just find it. I will not bore you with my amazing singing voice, but and I'm sure that there's better people who can sing this. But this is what happens when you use the quadratic formula. One thing that I do see students do is they go in and they're like, oh, here are 3 numbers. A is -1, B is 5, and C is 2. No, you want to put it in standard form. So this 2 needs to go in this direction. So we're going to have -x squared plus 5x minus 2 equals 0. Remember, we can't factor anything until we have something equal 0. It's just not a thing, okay? So now I know that I'm going to have A is -1, B is 5, and C is -2. Also, for those kids who tend to struggle with like, oh, I don't remember what A, B, and C are, or for those kiddos who like to add X in or X squared in for the A, B, and C, please write these things down. It will take you literally 2 seconds. It will be fine. No, nothing will explode, okay? Okay. All right, and then we're gonna do B, we're literally gonna replace the A, B, and C in here with these 3 things. So I'm gonna end up with -5 plus or minus, and some of the math, if you wanna do in your head, definitely go ahead and do it. Like I know 5 squared is 25, so I'm just gonna put in 25 instead of going and do 5 squared, so then I'd have to rewrite things. I also like writing this piece out because then it gives me a chance to think about, oh, there's 3 negatives. I know that this is going to be -8. So 25 minus 8 is 17. So -5 plus or minus square root 17 over 2 times -1 is -2. Final answer, this is what X equals. Again, like I said, there are going to be gross things. It's totally fine. Okay. So this one is really nice. I'm going to just extend this to make it another X instead of Y, but that's the problem said, A and Y, who knows why. And I'm going to go in and I'm going to say, okay, my A is 3, my B is -12, and my C is 13. If something is already negative and we need to make it negative, we're just going to make it positive. So 12 plus or minus -12 squared is 144, minus 4 times 3 times 13, 39, and 4 is 120, 36, 156. Okay. So now we're looking at 144 minus 156, which is going to be -12. So now we have an irrational number, not an irrational number, I'm sorry, an imaginary number of -12. All over this 2 times 3, which is 6. So one thing that we know about -12 as a square root is we have the square root of -1 and the square root of 12. So this becomes letter I. And this actually can be broken up into 4 times 3. Since we know 4 is a perfect square, we know that we're going to have 12 plus or minus square root 3i root 3. Sorry, not 3i. Oh my goodness gracious. 2i, I was looking at this 3. Root 3 over 6. For those of you who think you're done, you are not. In fact, you are not done only because in here I have the ability to simplify all 3 of these terms. In here I did not because there's an imaginary 1 and everything goes into 1, and 2, 5, and 1, there's nothing, no terms in common other than 1, so dividing by 1 doesn't even make any sense. But in here I can actually divide all of these 3 by 2, so this would turn into a 6, this would turn into a 1, and this would turn into a 3. So my final answer would be 6 plus or minus I root 3 over 3. I cannot simplify this anymore. I know this looks like a wonky looking 6. Let's fix that. I cannot simplify this anymore because I can't simplify just 2 things. I have to simplify all 3 at the same time. And since I've already done that, then I'm good. I'm golden. My answer is this in full. I guess also make sure that you put y equals instead of x equals because the original problem had y. And that was it, the first 8 problems in this review sheet. I hope that this was helpful, and I will see you in the next video in part 2. Bye.